This is a interactive 3D surface construction using marching cube algorithm project demo for Csci580 Grp15. Here we are starting our program. At the start, the grid is initialized and the initial grid dimensions will be 40 and this mode will be triangle mesh. Here on each mouse click there is a metaball spawn and it will be a series of metaball which will form a random object. Here we are going to create a random object which is a combination of letter S and letter C. Hence, by using our application, just by mouse click we can create any random object with a series of metaballs. So here we are completing our the random object with S and C. So basic grid dimension here are 40 and the display mode is triangle mesh. Now we can go for another display mode which is called as fill mode, which gives you the solid representation of the random object. So here is a fill mode. Through our application, the user has the facility to change the color of the object. Here is a demo for color change. Our application allows user to change the cube grid size. As the number of cube increases, the size of the cube decreases, tending to approximate the isosurface more accurately. Hence, here we increase the cube grid size to 48, 49 till 50. So here we can see the image becomes more accurate and fine. On the other hand, as the number of cubes in the grid decreases, we see more and more coarse structure of the surface. This is because as the number of cube decreases, the size of each cube increases. As a result, approximation of the isosurface become crude. So here we will now reduce the cube grid size below 40 and we can see there is a drastic change in the image and the image becomes more and more crude. Let us take this grid dimension to the minimum value 10 where we can see the image, and now we will increase it to the average value 40 again. Our application provides the zoom in, zoom out, rotation and the reset facility to the user to analyze the object correctly. Let us see how our application handles the zoom in and zoom out. So we are right now zooming out of the image and now we are zooming in the image. We will take it to the original zoom value again, and now we will see the effect of rotation. We will now rotate the object around the x-axis. Here is a rotation around z-axis, and here is a rotation around y-axis.